Okay, so we're going to look at the sample questions provided by the AP exam. I want to kind of just give you guys a heads up. So, obviously, this is a huge question. I mean, it kind of, if you look at it, it kind of goes on for just like all the way through G. And I want to remind you, you don't need to get 100% on this. So if you're like, oh, I didn't finish all of it, that's okay, right? I don't think I don't know what the expectation is, but it's probably not meant that you're gonna necessarily finish everything, and that's fine. So that being said, let's see what we can do here. Okay, so the velocity of particle p moving along the x-axis is given by a differentiable function v of t, where v of t is measured in meters per hour and t is measured in hours. Selected values are shown in the table. Okay, so we got these selected values and we have this velocity function. Okay, let's look at part A. So what do we got for part A? Justify whether there must be at least one time on this interval at which the derivative of v, which is the acceleration of the particle, equals 0. So this is an existence question. How do we know that the derivative has to equal 0? So the function is continuous. I mean, it's differentiable, therefore it's continuous. Since I'm going to do this in orange, since these two numbers are the same, right? Since v of 0.3 and v of 2.8 are both equal to 55, then by Rolle's theorem, there must be a c on that interval from 0 to 0.3 to 2.8 such that I'm just not saying the p because it's awkward, v prime of t equals 0. So let's go put that together. I don't know. The v sub p is just really awkward. I don't even know why they did that. Like, what was the point of that? But whatever. Okay, so let's see what we got here. So I'm going to say, so the function, so the function v of p of t is differentiable. And therefore continuous. Then I'm going to say VP of the two values given, what were they, 0.3 equals VP of 2.8 by mean, why am I saying mean? You could use mean value theorem, right? You could just say, hey, look, the slope of the secant line equals this, it equals 0, there, and go through and do it that way. But Rolle's theorem in this case is easier. So by Rolle's theorem, there must exist a c on 0.3 to 2.8 such that v prime of c equals 0. Okay? Moving right along, letter B. Use a trapezoidal sum for those given pieces to approximate. Okay, I'm going to go and grab my table again for reference. Let's do that. Got it. Let's paste it. Why does it go smaller when I do that? Okay, and we are just going to go, and we're going to do a trapezoidal sum that goes from all the way to 2.8. Okay, so let's go and do that. So in order to do a trapezoidal sum, I'm going to say, first off, I'm going to say for B, this value that they gave us, this displacement, or this function right here, is approximately equal to, okay, so let's do the trapezoidal sum. So remember, trapezoidal sum, you take the base and you multiply by the average of the heights. So the first base goes from 0.3 to 0, so 0.3 minus 0 is 0.3. Then I'm going to multiply that by the heights, right? So the first height is, it's going to be 55 plus 0 divided by 2, right? Because we're taking the average of those heights. Then I'm going to do the next one. I'm going to go from 1.7 to 0.3, which is 1.4. So 1.4 times the average of the heights, which is negative 29 plus 55 divided by 2. And then finally, I'm going to add the last one. So I just finished doing these two. So now I have to go and do the 2.8 to 1.7, which is 2.8 minus 1.7 is 1.4. And that's going to be negative 29 plus 55 again, divided by 2. Let me just double check that to make sure it's good. So 0.3, the average is the heights, that's 55 plus 0, looks good. 1.4, the average of the heights, negative 29 plus 55. I don't know why I went in that order, but I did. And then 1.4, negative 29 plus 55 divided by 2. Okay, looks good, and that's our value. They didn't ask us to do anything with it, so we are good to go. And that's actually part B. I don't think there's anything else that they're asking us to do with it. So let's move on to this next one. Okay, let me just make sure. Is there anything else? There's just, no? Okay, just seems a little weird. Like, feels like there should be something else they want us to do. But they don't. Okay, let's move on. So what do we got here? The continuous function f is defined on the closed interval from negative 6 to 5. The figure above shows a portion of f, okay, that makes sense, consisting of 2 line segments and a quarter circle, okay? And circle centered at 5, 3. I think they're telling us that so that we know the radius is 3. And it is known that the point 3, 3, so we know basically they're telling us what the height is right here. I'm assuming that's going to be important later on. So let's see what we can do. Letter C. We are supposed to, so if negative 6 to 5 equals that, find negative 6 to 2 of that function and show the work that leads to your answer. So what do we know? We know that negative 6 to 5 of f of x dx equals 7. But it also equals, I think you'd agree, it's got to be equal to negative 6 to 2, negative 2, excuse me, of f of x dx plus negative 2 to 5 of f of x dx. Now, let's see what we can do from here. So negative 6 to 5 is given. That's good. So that equals 7. We are actually supposed to find the second piece. So this right here is just going to stay as is. And then finally, what we're going to do is I'm going to add a bunch of stuff. I'm going to have to go figure out what is negative 2 to 5. So in order to do that, I'm going to grab this graph. I'm going to put it right here for, that worked well. That worked well. If I erase that, okay. I am really hoping I can grab that graph because I kind of really need it. Perfect. Kind of. Okay. Let's see what we got. So let's go find, now what we're going to do is we're going to go find all this stuff, right? So I want to go find this area. So I think you'd agree, if I go from -2 to 0, right, I have those two little triangles. So I have this triangle and I have this triangle, and they're going to cancel each other out. So from -2 to 0, I just get 0. Okay? Now, moving right along, I'm going to go find the area of, I'm just going to erase these pieces since I've done them. I'm going to go find that next little triangle, and notice it's below the x-axis, so I'm going to make it negative, and it's got so it's a triangle, so 1/2. The base is going to be 1/2, right? So the distance from here to here is 1/2. And the reason I know that is if you notice the slope of that line is 2. So for every 2 it goes over 1. So that's got to be 1/2. And then the height is, it's actually -1, but I've already dealt with a negative. Okay, so that represents this right here. I'll highlight it in red. This is the first, that little triangle. To that, I'm going to do this in purple for no good reason. I'm going to add the big triangle, right? So I'm going to be adding, I'm going to be adding this area right here. And that's a triangle. Its base is 1.5. So it's actually the area of a triangle, which is 1/2. The base, which is 1.5, times the height, which is 3. Okay? So I've done that, and then the last thing I'm going to have to do is I'm going to have to add the area of that, okay, which is it's a square minus, it's an awkward one. Right? If you want to go find the area of that, what you're going to do is you're going to take this entire square right here, and you're going to subtract the quarter circle. So let's go and do that. So that's going to be, so plus, let's do this in blue for no good reason. So the area of the square, right, it is a square, so it is 3 by 3 minus the area of that semicircle, which is 1/4 pi r squared, r being 3, so 3 squared. Okay? And that's a little bit, what did I do here? I'm going to let me change these. These are parentheses like that. Okay. Now, obviously what I'm going to do, right, is in order to find this, all I have to do is subtract, oh, that's awkward. All I have to do is subtract all of this stuff from the right-hand side. So in other words, because I don't want to simplify, let me simplify as I go a little bit. So my answer is going to be 7 minus all of that stuff. So what is that stuff? So 0, 1/2 times 1/2 is 1/4. So negative 1/4 plus, that's 1.5 times 1.5, which is 2.25, plus 9 minus 9/4 pi. Again, you didn't have to simplify it. You could have left it. In fact, maybe you want to, just to make sure you don't make any mistakes, because I may have made a mistake in there. But I'm going to assume for now that I didn't. Okay? So that is letter C. Let's move on to letter D. Letter D. What is letter D? Let's go and grab it. It's like a long problem. It goes on and on forever. Okay, we're supposed to evaluate that. So I'm going, in order to evaluate this, I'm going to say this right here equals 2 times this definite integral. And again, I'm just splitting this up. Okay? So continuing here, this is going to give me 2. By fundamental theorem, this will become f of 5 minus f of 3, right? Plus 4x evaluated from 3 to 5. Okay? And let's just make sure this should be a parenthesis there. Let's keep on going. So f of 5, sorry, what was it? F of 5, yep. F of 5 is 0. This is 2 times 0 minus f of 3. That's that awkward one that they gave us. F of 3 is that 3 minus root 5. So this is 3 minus root 5. Okay, so that takes care of the first part, plus 4 times 5 minus 4 times 3. Okay, letter D is done. Let's move along. Letter E. I'm going to probably, let me clean this one up. I'm going to grab this graph. I'm sure I'm going to need it. So let's go and grab it right now. Very awkward, this problem. Okay, what was I doing? I'm doing letter E. Okay. So what do we got? So the function g is given by, it's basically given by the graph, really. Find, well, the integral of the graph, should I say. Find the absolute maximum value of g on the interval from -2 to 5. Justify your answer. Okay. So, of course, absolute maximums occur when the derivative, we're going to look for critical points, right? So, in other words, I'm going to say g of x equals -2 to x of f of t dt. Then g prime of x is going to be equal to f of x. And I want to know, for my critical values, I want to know where does that equal 0. So I'm going to say g prime of x equals 0 when f of x equals 0. I don't know if I probably don't need to say that, but I'm just going to do it anyway. So these are going to give us our critical values. And I think you'd agree our critical values are going to be at -1, +1/2, and the 5 is an endpoint, which we're going to have to consider anyway. So since it's asking for an absolute, we're going to have to consider the endpoints -2 and 5 plus our critical values. Now, before I do that, just because I'm going to be a little lazy here, I'm going to make a quick sign chart to see what's going on here. So from -2, we have a critical value at -1, we have another critical value at 1/2, and then we have an endpoint at 5. So from -2 to 1, notice the graph is positive, so the derivative is positive. Then it's below the x-axis, so it's negative, and then it goes positive. So what do we have? We have a maximum here, a minimum here. So I think you'd agree 1/2 I can ignore. It's a minimum. So it's not one of the values that's important. So what I'm going to do is I'm going to be evaluating g of 2, right? I'm also going to be evaluating g of -1 because that's a maximum. And then finally, I'm going to be evaluating g of 5 because that's another one of my endpoints. Okay, so g of 2. Well, that equals -2. It's not, I'm sorry, I'm saying g of 2, but it's not g of 2, it's g of -2. Hopefully that did not confuse you guys. Hopefully you recognize I was just saying it incorrectly, right? Because that's the endpoint. So from -2 to -2 of f of t dt, and that just equals 0. Then let's go to -1. So this is going to be the definite integral from -2 to 1. a negative 1 of f of t dt. And looking at that, we are just looking at this little triangle right there, which is positive, but it's got a base of 1, a height of 1, so 1/2 times 1 times 1. So the whole thing is, whoops, positive 1/2. And then g of 5, which we've actually already done, right? We've actually already figured this out before. Very conveniently, right? We did that up. Where did we do that? We did that here, right? All this stuff right here. This piece right here. This, just let me make sure I'm correct. This right here is g of 5, right? 1/4. Yeah. So what I'm going to do, to be super lazy, is I'm just going to copy it. Copy. So that equals this. Now, unfortunately, let's just check and see which one of these, because they're asking us, did they ask us to find it? I need to see, I want to make sure this is greater than 1/2. So let's see. This might be one of those situations. I don't know why they made this such a bad number, because it just seems like it's going to slow you down here. So let's see. Negative 0.25 plus 2.25 plus 9 minus 9 pi over 4 equals 3. Why did it give me 2 as a decimal? Okay. Hopefully I plugged that in correctly. If I didn't, I apologize, but I got 3.931. So this is my answer. By the way, I didn't have to, if you recognized that bracketed piece was greater than 1/2, you would have been good. So the last thing we just have to say is maximum value is, and I'm just to, because I've already done it, is 3.931. Okay. Let's, again, hopefully I added those things up correctly. I was using a weird scientific calculator that I'm not comfortable with, but let's assume that I did. And what letter are we on? We just did D. Is that right? I just did D. Okay. Let's go do, no wait, I did E. I'm sorry. So let's move on to F. Okay, so I'm going to grab that, and I'm going to grab the picture again. What an awkward problem to do as a video. Okay, what do we got here? We're supposed to find the limit. Find the limit. So again, with limits, one of the first things we should check and see is, can I just plug the number in? Because if I can, then that's great. So let's go and see if I can do that. So let's plug it in. So I get 10 to the 1 minus 3 times f prime of 1 over f of 1 minus the arc tangent of 1. Okay. Again, if this doesn't work, I'm going to have to go do something else, but let's just see if we get a number out of this. So this may be weird, useless stuff. So 10 to the 1 is 10, minus 3, f prime of 1, right? It's the slope of this line, which we already said was 2. So it's 10 minus 6, that's fine. F of 1, right, is actually the height of this function there, so that is 1, minus the arc tangent of 1. Arc tangent of 1 is pi over 4. And that looks like a number. So F is done. Let's move on to the last one. Nope, where is the last one? I think. Yep, here it is. Here it is. Let's grab it. and move it down here. And I'm going to grab one last time, I hope, or not hope, it's going to be last time, right? I'm going to go grab this graph and move it here. So what do we got? Suppose g of x equals that function. Is the rate of change in g increasing or decreasing? So the rate of change is the derivative, but they're asking, is the derivative increasing or decreasing? So they're asking for the second derivative, right? Because increasing, decreasing represents a derivative. So they want to know, is the rate of change of g increasing or decreasing? So is the second derivative positive or negative, basically? Okay, so let's go find that out. So first off, I'm going to say g of x equals negative 2 to x of f of t dt. And I think you'd agree. So the first thing I'm going to do is I'm going to go find that rate of change of g, which is g prime of x. And that's going to be equal to f of x. But that's not what they're asking for. They're asking for the second derivative. So I'm going to go look at so g second derivative, g double prime of x equals f prime of x. So now I want to know at t equals 1, right here, right? I want to know, is this value positive or negative? So let's go and figure that out. So remember, that when I'm saying that value, I want to know what is this value right here. What is g double prime of 1? So g double prime of 1 is the slope of the tangent line to that point, which we already said was 2. So the second derivative is positive, which means that our rate of change is increasing. So putting that all together, I'm going to say, let's see how I say this. Since how am I going to say this? I'm trying to put this together in some way that actually makes sense. Okay, since, actually let's maybe type this. I haven't been doing typing for some reason, and I'm sure you guys would appreciate me typing it. So, where is it? Boom, but nope. Boom, 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 boom. 14, 15, 16. Okay. So, since g double prime of 1 equals f prime of 1, which is greater than 0, right? Because we said is equal to 2. The rate of change of g is increasing at x equals 1. And that is our problem.